Hello everyone, welcome back to Structures courses. Basically, we're going to have the Design of Reinforced Concrete course, CS4702C, and this is building on the information that you studied in statics, mechanics of materials, and strengths of materials. So I just want to make sure that every one of us is fulfilled and passed mechanics of materials and analysis of structures with a grade of C or better. So if you have any conflict with that or just like didn't fulfill that requirement, please get in touch with me. By the end of this semester, we'll be able to design reinforced concrete slabs, one-way slabs, and beams in flexion and shear, and we're gonna design beams for deflection and slabs for deflection, and you're gonna be able to design columns, and if time allows, we're gonna be designing foundations as well. Usually I take the students for field trip, like in Orlando when we went for the hospital that was built for UCF, and we observed the construction, the design process, and the construction of columns and slabs and some footings as well. And that course also will make you appreciate the amount of effort that has been done in design and the construction of skyscrapers and high-rise buildings, and to get to know how to design slabs and what is the structure system, what are the difference between these kind of roofing systems, or rather concrete floor systems that you're having right here. You will hear this kind of terminology about flat plate, flat slab, drop panels, and you're gonna have one-way slab, two-way slabs, waffle slabs, and so on and so forth. So by the end of this class, I assume that you will be able to be familiar with the concrete itself, and you're going to be use the information that you studied in civil engineering materials in the other three classes of statics, mechanics of materials, and structure analysis, and now in the reinforced concrete to be able to design the main reinforcement that you see right here for beams, for instance, and the secondary reinforcement and the ties or the transverse reinforcement. I also used, and I wish able to take you guys for a field trip rather, to GATE Precast, so that you can see some components. Like this group of students that I have, we were able 2 years ago to go to GATE Precast to observe the construction of this hollow core slab. It's concrete, and observe how they do this pre-stressing, like stretching the cables, and how they cast the concrete, and that was so good, and it adds to students. As I mentioned to you earlier in previous classes, we were able to go to international field trips to see the repair of concrete and masonry structures, and to see and observe this kind of seismic activities and deformations and cracking of structures as well. And I shared with you before my experience 20 years ago when I was at FSU in Panama City, and we had the Ivan hurricane, I believe, 18 years ago, and that basically destroyed parts of the I-10, and we were able to just quantify the amount of force and how much force is being exerted. And I partnered with underwater crime scene investigation through the FSU in order for us to know exactly the amount of force and that basically how much uplift force was exerted on these panels and the drift, or rather the shift of this structure. So I hope that you're going to enjoy this class and build a very strong background on structures that will help you, even if you're not going to major in structures. But it's really nice to be knowledgeable about all fields of civil engineering. Going to our syllabus, I just want to share with you what I posted is that this course has a prerequisite of CES 3100, which is the analysis of structures, and it also has the description, which is basically telling you that you're going to be studying the behavior of concrete structures. American Concrete Institute, which is the ACI, you don't have to purchase that. The equations of the ACI are listed in the textbook, and I advise you to read that textbook. It's very nice to read, it's very easy to read as well. You will be able to design reinforced concrete structure members, and you're going to be able to identify failure modes. So what is the failure mode for this beam, what is the failure mode for the slabs, what's the failure mode for the columns as well. And you're going to be able to design something called T-section, rectangular section. And you're going to be doing some double reinforced section as well. The objective of this course is to analyze the concepts of reinforced concrete and to understand the behavior and how is that behavior conforming with the specs of the ACI or the American Concrete Institute. And the other objective is to design reinforced concrete components under shear and bending moment and axial force. The very important thing that I want to highlight as well is that the format of this course, it is not a Zoom format. It's not Zoom meetings. It is online, 2 lectures, asynchronous, so that you can listen to those on your own, and you can just watch these videos on your own afterwards. Yet, for any question that you have, you can communicate with me via email, or we can schedule some Zoom meetings if needed. But this is not Zoom meeting classes. This is an online format. And this semester, since I have heard from several students that they want some sort of rigid schedule, and definitely I am going to do that this semester. You're going to be tested 9 tests, basically 4 tests and 5 quizzes. A very simple one at the very beginning. It's just like welcome kind of quiz to see your participation, and that's going to be Friday. And that is worth 1% of your grade, which is 10 points. And then you're going to have other parts as well. Okay, let me get back here. It's a welcome thing to identify yourself, but at the same time, you're going to be tested on some aspects of materials that you need to know before you go to reinforced concrete. The stuff that you studied in analysis of structure, the stuff that you studied in mechanics of materials and statics. It's basically reactions, shear and moment, and the moment of inertia of a cross-section and the parallel axis theorem. So you'll be tested twice, quiz 0 and quiz 1. One of them is 1% of your grade, the other one is 3%. So it's very minimal, and that is giving you an opportunity to show your work. The dates are here, and if there is any mistake or anything as far as the dates, as far as whether it's Thursday or not, or Wednesday, just let me know. And most, if not all, of the tests are going to be honor lock. So it's either Canvas online tests or honor lock. So be prepared for that, so that we will be able to perform very well in this class. We take that class very seriously. It's a design class, and the community in Florida, in Jacksonville, basically are expecting our graduates to be very competent in this stuff. So I assume that we're going to reach a certain minimum requirement. You achieve the minimum requirement so that you can pass this class, and it is easy to pass. It's challenging a little bit, but I'm sure you will rise up to these expectations, and you're going to perform very well in this class, and you will be able to show your understanding of all of those, the material properties, which is what you studied before, the flexure, serviceability, and crack control, and all the other stuff. Just wanted to share that with you, and I'm looking forward to a very good semester, and I'm going to start posting some information and some helpful materials so that you can start studying. So looking forward to this semester, and let me know if you have any questions. Thank you.